Hi, my name is Tom Chandler, and my third year project is Science Lab in the Web. My tutor is Christopheros Moutafis. The aim of Science Lab in the Web is to improve the web presence of labs and active research group using modern technologies. The reason for doing this is that it's important for the public to have an understanding of what is going on in science. It is useful to provide a streamlined way for interested parties such as investors to review research, and information sharing can lead to innovation. I started out by evaluating the current situation. I found that labs generally output content on their own websites, and unless you already knew about the lab, you wouldn't find the content. I also found that untrustworthy but highly engaging content is widely available for free on social networks. This led me to come up with a solution which can be broken down into three parts. I made discovery of labs and their research easier by creating a centralised platform to host their web presences combined with internal and external discovery functionality for users. I aim to make posts digestible by providing the means to produce content in a way that social media users are familiar with. I wanted to encourage trustworthy content by only allowing original posts from research groups. This removes the free-for-all mentality found on other social networks and removes the possibility of the meaning of a group's research being twisted and posted by a third party. On the back end, I decided to use Google Cloud to create a microservices architecture. This provides scalability as each service will automatically horizontally scale when the number of concurrent requests for a service reach the threshold value. This results in little or no downtime regardless of user base size. I can also easily extend functionality in future by adding new microservices. The database is made up of the NoSQL file store for storing the majority of data and cloud storage for cheaper storage of large files such as images and videos. Algolia is the API which allows me to provide a full text search to my users, which I'll go into more later. I use Cloud Functions to handle messaging between different services and my front end. Cloud Functions are standalone JavaScript functions which can be invoked by HTTP requests or microservice events. I used a combination of Cloud Functions and Express to create my API. Express allows me to create an industry standard API by routing relevant Cloud Functions through the same endpoint. When compared to using Google's Client SDK, this technique allows me to reduce package size, therefore improving web app performance, prevent users directly accessing the database, therefore improving security, and to separate business logic from the view, allowing for the possibility of extending the platform in the future, maybe with a native mobile app. On the front end, I used React with the Next.js framework. This provides automatic performance optimizations through code splitting, but most notably it allows me to score very high search engine optimization scores, which I'll go into more later. I use Redux, which allows me to manage global application state easily, and Material UI, which is a UI framework which encourages best accessibility practices. There are three main view types on the platform: the homepage, user pages, and lab pages. When not logged in, the homepage displays the latest posts by all labs. When logged in, the home feed will display a curated feed of the latest posts from labs that you have followed. User pages are pages owned and customized by individual users. The feed will display posts that the user has liked. If they are a lab user, a filter will appear which allows you to view their original posts. Lab pages are the actual web presence of labs on the platform. They are customizable and they display all posts that have been made on behalf of the lab. Users without an account can read articles and take advantage of discovery features. If they try to use more advanced features, however, such as commenting on and liking posts, they'll be prompted to sign up. Once users sign up, they receive their own user page, and they can take advantage of the advanced features. The reason for using this structure is to be able to show the value of using the site to potential sign-ups and then nudging them to create an account. Signing up users is beneficial as it increases the likelihood that they will return to the site and engage with the content. Having a more active platform will also make it easier to attract new labs to sign up to the platform, which in turn creates more content and more interest. Lab users are users that have accepted an invite to join a lab. These users can then create original posts on behalf of the lab by going to their lab page, choosing the post type they want, and adding the necessary information and files. By only allowing posts to be created on behalf of labs, there is an incentive for labs to keep post quality high, as it directly affects how the lab is perceived. I gave posters the option to create video, slideshow, and article post types in order to encourage labs to create engaging posts in digestible formats which social media users will be used to. I also provided a study post type so labs could upload more detailed research if they felt it necessary. They can also create hashtags to accompany the post, which will allow posts to be more easily found by users. Lab admins have the same ability as normal lab users, but have extra permissions to invite new lab users, promote lab users to admins, and remove all permissions of current lab users. This allows labs to control access to their pages, for example if someone stops working at the lab. The main features of the site, however, come into play with the ability to discover new topics and labs. The internal discovery features are search, hashtags, and trending posts. I implemented a full-text search ability using cloud functions and the Algolia API. Users can type in the name of a lab or user on the platform, and a search with suggestions will be performed in real time. I've created a cloud function which will trigger automatically when new users are added to the database in order to add them to the Algolia index. This type of search, while a useful feature, does not provide any extra functionality over just searching for known labs in a search engine. Therefore, there was also the need to implement features which would allow users to discover new labs and new research that they didn't know existed. Hashtags are useful for exactly this reason. Clicking a hashtag, such as on posts or in the suggested bar, will trigger a single term search of the database, looking for posts with that hashtag. The user will be taken to a feed containing the post returned by the search. This is beneficial as from here users can discover new labs and research related to the topic they are interested in. Authenticated users can also follow hashtags they like for easier access next time round. Trending posts is a list of the most popular posts created within the last 24 hours. Every time a post is viewed, a counter will increase in the database. I've set up a cron job using the Cloud Scheduler microservice, which will trigger a cloud function every hour. This cloud function searches posts created in the last 24 hours and sets the top 10 most viewed out of these to be the currently trending posts. This is useful as it encourages users to discover areas of research that are outside their normal sphere of interest. It also gives a way for users to stay up to date with what others are currently most interested in. I have also implemented external discovery features. These are features which take advantage of infrastructure created by others to make the content on LabLink more discoverable. Any posts on the platform can be shared to external social media sites. This will create links back to LabLink. All authentication for these sites is handled by the site themselves, so there are not any extra security or ethical considerations that need to be taken into account. The purpose of this functionality is to allow users to share posts they are interested in with friends on other platforms. It also provides a mechanism for organically advertising LabLink to people who haven't heard of it, which would hopefully drive traffic to the platform and increase interactions on the platform. The last feature takes advantage of the way search engines index and rank websites. Search engines use web crawlers to find and index new web pages. Once this is achieved, web pages can be displayed as results to relevant queries in the search engine results. I use the Next.js framework, which allows me to create an isomorphic web app. An isomorphic web app is one which uses server-side rendering on full-page reloads to provide fast initial page loads, whilst taking advantage of the speed benefits gained from client-side rendering when navigating through client-side routes. When a web crawler accesses a page on my site, the page will be rendered on the server side first, and then passed to the crawler as a static HTML page, which can easily be crawled and indexed. If I had chosen to use 100% client-side rendering on my website, my search engine optimization lighthouse score, as shown here, would have been much lower, as web crawlers are classically poor at retrieving indexable HTML from JavaScript files. Overall, the benefit of this approach is that lab pages and posts on the platform will appear faster in search engine results and will have a greater likelihood of ranking highly for relevant search terms, thus making them and the website more discoverable. Additionally, I produced a test suite for unit tests for my React components using Jest and Enzyme. This allows me to evaluate code quality as I go and make sure no changes I make break the system.